impacts threaten entire communities. The sea rise is being driven by melting coastal glaciers in the high polar regions and by the slow expansion of the warming oceans. Recent studies warn that all of New York's subways and tunnels could flood, and Miami's beachfront hotels could be hit by 15-foot-high storm surges. But in late August of 2005, the warning flags along the Gulf Coast were flying. New Orleans sat waiting well below sea level, protected by a levee.
Right now it's about 17 feet above lake level, and in Hurricane George, it got within about, I think, 2 to 3 feet of the top of the levee. So of course now we're all thinking about building levees a little bit higher.
It didn't work. The aftermath of Hurricanes Katrina and Rita has become America's most documented disaster. But the devastation of the Gulf Coast has been underway for decades. Before Katrina destroyed his lab, Shay Penland spoke with us from a Louisiana barrier island.
Just this last fall, we had 2 storms. Right where we're sitting right here now, the shoreline eroded 290 feet in a week. Since 1932, we've lost over 1,000 square miles of land.
In fact, the Mississippi Delta was losing the equivalent of one whole football field of dry land every 15 minutes. But just as frightening, southern Louisiana has the nation's only deepwater offshore oil port. This was Port Fourchon before Katrina, and this is now.
This one little place on Earth plays a strategic role in somewhere between 16 to 18% of this entire nation's hydrocarbon supply. And with coastal land loss on both sides impacting the highway, the vulnerability of our energy supply is increasing daily. We also have about 20,000 miles of pipelines in coastal Louisiana that were designed for being under the marsh and not for being in the Gulf of Mexico. So as the sea level rises and land subsides and the sea takes the land, those pipelines become exposed to a much harsher environment than they were designed for. And you just can't replace 20,000 miles of pipelines overnight. So it's a tremendous environmental situation that we're going to have to deal with in this next 20 to 50 years, starting now.
Follett's fears were justified. Soon after Katrina and Rita, the infrastructure struggled at far below capacity, and U.S. gasoline prices soared to unprecedented heights. The climate patterns that may have contributed to recent Gulf Coast disasters have left far too little moisture in the American Southwest. The drought that started here in 1996 had, by 2004, killed off most of the pinon trees across 3 million acres.
Old-growth forests and woodlands here in the Southwest take at least 200 years to grow and develop. Yet a severe drought like this can cause those forests to die back in just a couple of years. The bark beetle outbreaks.
So we're dealing with serious questions. The world's foremost food crop is at risk. Coastlines are eroding. Our western heartland is drying up. And human health is under threat. The more science we do, the more we understand how future climates might work. But some of those findings may bring unpleasant surprises. Could we be nearing some invisible tipping point where sudden changes in the climate stop civilization in its tracks? Or could Mother Nature turn on us? A case in point. It's widely assumed that forests store away much of our excess CO2 emissions, which help us breathe better. But investigators in the Rocky Mountains have unsettling evidence that an excess of fixed nitrogen coming in from the atmosphere may be upsetting all that.
We're studying nitrogen because it is part of the carbon dioxide story. You, me, plants, every other living thing on Earth is made up of carbon plus other elements, other nutrients. And nitrogen is one of those, and in fact, it's an essential nutrient. Now, it's interesting.
Basically, like you or I, anybody else, the soil and everything that lives underneath there, plants and microbes, breathes. So as they breathe, just like us again, they're releasing carbon dioxide.
What the team is investigating is whether elevated levels of nitrogen in this soil are stimulating microbes microbes into a feeding frenzy down in the old stored carbon.
So by adding nitrogen, the hypothesis is that we've given them more access to that food. More respiration, more carbon dioxide coming out of the soils.
If nitrogen is triggering the release of more stored carbon, where's that nitrogen coming from? Well, apparently it's coming from us. Every time we burn fossil fuels, we produce nitrogen. Every time we fertilize fields or manure piles up, we're spreading nitrogen around.
In Colorado, we have this very nice situation where we can actually pinpoint where our pollutants come from because there isn't very much out of here. Every night when cold air drains down from the bottom of the mountains, because you know cold air sinks, it sinks down to an area in the middle of the South Platte River Basin, about the town of Greeley, and it pools there. So all the air pollution that comes with it from Denver and from the agricultural fields pool down there, and every morning when the air rises, as it warms up, it comes back up the mountains. So it's coming from Greeley, from the lower part of the mountains, against the prevailing winds, because it's moving with hot air rising, moves up here to the tops of the mountains where you get summertime clouds. These summertime clouds condense, take all those pollutants, dump them down on the ground. And that's where we're getting the nitrogen.
If this nitrogen cycle is repeated elsewhere, many of the world's forests won't be absorbing much CO2. They may even start releasing it. Out at the far end of the climate spectrum is a worst-case scenario in which an increasingly warm atmosphere would trigger abrupt climate changes. Unpredictable and stunning shifts in both temperature and precipitation that can bring on almost instant drought or deep freeze, devastating perhaps just one region or the entire planet, and lasting for decades, even centuries. It has happened before.
We've only known for about 15 years that the Earth had this capability of undergoing large, this means global, abrupt, this means a couple decades, changes, so that the whole system has reorganized many times in the last 100,000 years.
Brooker believes the trigger lies in the North Atlantic. Much of northern Europe enjoys ice-free conditions all year, thanks to an ocean conveyor belt that transports warm water from the tropical Pacific and up the Atlantic. When the warm water contacts cold Arctic air, it cools, becomes saltier and more dense, and sinks to the ocean floor, returning south on the same path. But if fresh water from melting glaciers and icebergs is added, the current's density is gradually reduced and it can't sink to the bottom. The whole system stops operating, and rapid climate shifts may quickly follow, some lasting up to 1,500 years.
These events start and stop in less than 10 years. Arguably, some of them start and stop in less than 2 years, and they are immense events. The ones that occurred more than 12, 14,000 years ago were events that were so dramatic that there were changes in places like Greenland on the order of 10, 20, perhaps 25 degrees centigrade shifts in temperature that occur in less than 10, maybe less than 2 years. None of these rapid climate change events is going to suddenly result in a massive ice sheet dropping from the sky and covering North America, but we don't have to experience anything anywhere near that big and to be very, very vulnerable to climate change.
So we're doing a dangerous thing. We could luck out, or we could have the worst case scenario. So prudence would say, for God's sake, stop putting CO2 in the air as rapidly as possible.
It was hoped that the Kyoto Climate Protocol in 1997 would start doing just that, by establishing targets for developed nations that would reduce their carbon emissions to 1990 levels. After that, developing nations like China and India would adopt similar limits. But with a U.S. refusal to sign, the effect of the Kyoto Agreement will be limited. What's of more concern to many of the world's scientists and environmentalists is that Kyoto was only a first and very modest step.
The likelihood is we would need probably 10 or even 20 times Kyoto level reductions to reduce CO2 forcing in the atmosphere to a point where climate change is no longer a problem?
I don't think the planning is adequate. There are some very long time constants built into this thing. When you put emissions of carbon dioxide into the atmosphere, it takes a long time for that to have its full effect because the oceans heat up very slowly. Sea level rises very slowly. And so these things have ramifications for decades, centuries into the future. And so we need to start planning for it as soon as possible, and I don't think we're doing that.
And remember, it took 100 million years of the coevolution of climate and life to give us the distribution and the kinds of species we have. And to have one generation or two generations of one species, us, so climb over each other to get richer faster that we didn't stop to think about what kind of damage we could be doing to tens of percent of the rest of the creatures. I think people in the future might look back at our generation and say, what was wrong with their value system?
This is not primarily an economic issue in my mind. This is primarily a moral issue. And to ignore it means putting billions of people at risk around the world who are much more vulnerable to the immediate impacts of climate change. It means dishonoring the work of all these generations of men and women who worked so hard to bring us the civilization that we enjoy today. And it really means consigning our children to a future of disintegration.
So what can we do? If we agree global climate change is taking place, there are two approaches that will work just as well for us as they do for companies and governments. First, on an individual level, we can start adapting to the new realities of a new climate. Prepare ourselves. Second, and just as important, we can slow down the rate of global warming by reducing our impact on the atmosphere. Basically cleaning up the way we live. That's where a lot of Americans are putting their efforts. The kids at Harper's Choice Middle School belong to a generation likely to be most affected by global warming. Happily, they seem to understand that and enjoy getting involved with environmental programs like the Energy Alliance.
Before I started Energy Alliance, I would never turn the lights off, always leave them on. Now I'm getting a lot better, and I'm putting the computer to sleep, which I learned saves a lot.
2 computers are on. That's also not good.
Here in Maryland, these kids are auditing their school to check for energy wastage.
So she gets a friendly reminder. Okay.
Teachers who leave lights and computers on are given a ticket and told to be more careful. The kids love that.
I got a friendly work harder. Since I left my lights on and the computer on.
The program allowed us to develop in kids a real passion, an interest and a passion for what they do, particularly in this case in the environment. I mean, these are the kids who, as they get older, will get actively involved in the environment, in our planet.
All over the world, it seems, this is a message which kids understand and care about. Here in Beijing, at the Showpiece Eco School, good citizens of tomorrow get ready to take this message to their homes and families. Change your life. Help slow down the global warming. The impact of carbon pollution worries the Beijing authorities as they prepare to host the Olympic Games. China recently set new emission standards that are stricter than most of those in the U.S., though actually enforcing them countrywide may prove more difficult. In Beijing, however, taxis are given many incentives to convert to natural gas. At least one cabbie has found that it's cheaper and healthier, and you don't have to speak Mandarin to understand his relief.
因为一旦摇上以后，呛眼睛和鼻子很难受。就说从这个烧了气以后，北京市这个天气变化很好，太好了。
For China, this is a first step on the road to cleaner air. In the U.S., however, there's an uphill battle to change the car culture, mainly to introduce clean technologies that could steer our automotive obsessions in the right direction. This is the annual Future Truck Competition between 15 university engineering schools. The challenge is, whose new technology will outperform its gasoline counterpart and burn fuel cheaper, cleaner, and more efficiently?
This truck behind us is a split parallel hybrid electric diesel electric hybrid. Transmission parallel hybrid. Hydrogen fuel cell power. Ethanol electric.
Diesel electric hybrid.
Hybrid diesel electric vehicle with a modified 4-liter with a small internal combustion engine and a powerful electric motor.
Top prize trucks and buses already on the market, and not necessarily where you'd expect. In 2001, the Sheriff's Department of Martin County, Florida, became the first law enforcement agency in the country to add hybrid vehicles to its fleet.
Well, I'm always looking for new things. I like to be on the edge in technology, and I'm always willing to make a change if I have confidence that it's the right thing to do and it'll have a benefit. So it wasn't a big leap for me. I was kind of eager to try it out.
Sheriff Crowder now has a number of different hybrids in his fleet of 22, and that number is growing each year. The first payoff has been an impressive 60% reduction in fuel costs. The cars are used for a variety of non-pursuit applications, in most cases replacing aging, low-mileage police cruisers. And acceptance is growing.
Some of our friends made fun of us because this isn't a normal police car. When they gave me mine, I had mixed emotions, but I enjoy that car now, but it's part of my job is to drive through neighborhoods or look for either suspects or sometimes we have to do runaways. If you're in a regular police car that's unmarked, people pick up on it really quick. They don't even give my car a second glance.
Beyond hybrid technology may lie the much heralded hydrogen economy. But even its advocates agree it's at least a decade or more away. In the meantime, some very bright people are simply doing ordinary things a different way.
5, 6, 7, 8.
This is a rehearsal for Climate Change, the Musical, in Keene, New Hampshire. People here are excited about meeting the challenge of keeping Keene green. The city council decided to do what they could by reducing carbon emissions in every activity controlled by the city. They're using low-polluting biodiesel fuel in all their trucks and heavy equipment. And while this recycling plant looks fairly standard, it's actually powered by methane, which comes from the old landfill next door.
This is one of 17 interconnected wells that basically supply a pipeline that directs down to that blue building down there, which is simply a diesel generator that's been modified to run on methane gas. And it goes into our electrical transformer, and three-phase power is produced and single-phase power is produced. We came up with a business case, essentially, that showed that producing our own power on site was not only feasible, it was highly desirable and very favorable from an economic standpoint. The power company sends us a bill each month. It's about $7, and it's the cost of mailing us a bill.
So then, how about you? How about what you do? You drive that big car just to go to the store that's just 1 mile away. Don't get us started about how hard you are.
Small wonder the people of Keene are embracing their new green identity.
Okay, well, there's something else over here I'm going to show you. This is really cool.
There is a revolution going on in energy-efficient home construction all over the world, and it's being spearheaded by radical young architects like Chris Holmes. Just a few years out of architecture school, he's reinventing the concept of affordable green living.
In a few years, we're going to have a big eco-building empire across the country, I have no doubt.
This is a working-class neighborhood in Montreal, where Holmes has developed a radical concept for affordable multifamily housing. Each 2-story unit is cheap by big city standards, less than $150,000 US. They're cheap to rent or buy, and even cheaper to run. A homeowner will only pay about $50 US a year for heating, cooling, and hot water.
Okay, so what we did here is we brought the windows out of the building in order to maximize the amount of sun coming into the building from the sun as it travels across the sky. That light energy is coming in and stored in the concrete floors, and that helps to provide over 60% of the heat for this building. Up on the ceiling, this whole ceiling acts like a giant radiator, either circulating heat or cool, depending on the season. That's provided by our geothermal heat pump in the basement. And finally, we have a lot of energy recovery techniques that we use. We recover energy from all the waste water. We recover energy from the waste air that goes out. We also have incredible windows in this building. This is really cool.
As Chris's projects are demonstrating, there are untapped reserves of geothermal energy everywhere underneath us, not to mention independent, emission-free energy from sources and technologies that already exist. In In fact, wind farms near Altamont, California have enough capacity to supply electricity to 500,000 households. And a federal study estimates that wind power potential in the Dakotas, Kansas, and Texas alone could supply all of U.S. electrical demand. But even that doesn't match the potential of the sun. Each day, more solar energy hits Earth than its 6.4 billion people could consume in 27 years. But you don't have to live in the Sun Belt. Contractor Lyle Rawlings is bringing solar into the energy mainstream in New Jersey by helping union electricians learn the ins and outs of the technology.
Solar energy is actually the most intensive job creator of any form of energy. It creates 4 times more jobs per kilowatt hour generated than fossil fuels such as coal. It's manufacturing jobs, it's installation jobs, it's technicians that do servicing. A lot of high-quality technical jobs that are being created right here in New Jersey.
At the top of the customer satisfaction list is the moment they start selling electricity back to the power company.
And as soon as we flip the switch, we'll see that meter slow down and stop and then start to spin the other way. And people love to see that.
It's too good to be true. The sun comes up and you produce power. Why are we not doing this? There are no emissions. And there's no cost of the power. Why are we not doing more?
Tom Layden's company produces large-scale photovoltaic arrays. His Fortune 500 customers see solar as a long-term investment, and Layden hopes more politicians will start to do the same.
It really comes down to policy. All we have to do is grow the industry like it's growing right now, and we can produce 100% of our power in the next 35 years. This system alone will save about 5,000 tons of CO2 production over the next 30 years. In terms of barrels of oil, that's 28,000 barrels of oil, the equivalent energy that this system will produce.
For many of those 30 years, over half of U.S. electricity will still come from coal-fired power plants. And the older plants will remain among the country's worst contributors to air pollution and atmospheric warming. There are new technologies that would let countries like the U.S. and China use their huge domestic coal reserves and reduce some of the pollutants. Coal gasification is a partial solution that produces 50% more power and cuts most of the sulfur and nitrogen, which reduces both smog and acid rain. But its CO2 emissions are still a problem. On the horizon is a truly zero-emission coal technology. But in the meantime, our atmosphere keeps on warming. Research to reduce CO2 emissions is happening in some surprising areas. Agriculture and land clearance have been part of the problem, contributing up to 20% of all the world's greenhouse gases. Now, they may become part of the solution, if scientists have their way. In this experimental field, they reduce the fertilization, computers control the irrigation, and there's minimum tilling of the soil. What they're looking for is an answer to a fairly simple question.
To what extent can some of our major cropping systems here in the central USA Corn Belt contribute to alleviating some of the greenhouse gas emissions that are occurring? So here at the University of Nebraska, we have a production scale field experiment. These are not small plots. And we're using progressive management practices that we think are going to be those practices that farmers will be using in 10 to 20 years. We're asking the question, under those conditions, how much carbon can they store from the atmosphere? Because plants fix carbon dioxide in their tissues, and if the net balance of that fixation is greater than the emissions of carbon dioxide from the cropping system, then we have a net carbon sequestration. That means that we're storing carbon in the ground, in soil organic matter. And that then would contribute to a reduction in the greenhouse gases in the atmosphere.
If these plants can store some of the excess CO2, perhaps artificial plants could do even more. In the New York City suburbs, 16-year-old Claire Lackner and her father Klaus are working on a great experiment. Their goal is nothing less than to undo the damage of global warming.
Well, the basic idea was just to use different chemicals to collect carbon dioxide. So like we used a fish pump just to pump the air through the solution on looking at this tower that he's designed that is basically the same idea, just a lot bigger.
Klaus's plan is a landscape of synthetic trees, inhaling CO2 out of the air just like real ones. The leaves on his trees will be giant veins saturated with chemicals like calcium hydroxide. When the wind blows, that will react with CO2 in the air to form harmless calcium carbonate, the stuff of seashells.
Limestone.
The chemistry seems reasonable, but the towers will have to be very large.
If you want to put that in perspective, if you look at the skyline, it would be comparable to these buildings you see over there.
There's another way to do this.
On the
With
order,
things the size of a tractor trailer, semi,
which we collect
that part,
thing stands on a
instead
pedestal,
of the big tower.
maybe another 50 meters tall, so the wind collecting area is on the order of 160 by 200 feet.
Each device would collect the continuous excess CO2 emitted by 4,000 people or 15,000 cars. To deal with all of today's CO2, we need 250,000 towers, which could be anywhere, because CO2 is everywhere. Plans like the Lackners may be optimistic, but funding for a prototype is in place. So could these radical solutions and best efforts actually stop climate change? Well, it's pretty clear that with a world growing so quickly, in so many ways, it can only be slowed, not stopped. Climate change is deceptive because its signs occur almost imperceptibly. So the question becomes, what happens next? Can we wait for new technologies to save the planet? Or for governments and big business to take the first steps? The fact is, many solutions to slowing down climate change are already here, or very close. We just have to start using them. Because every day our glaciers shrink, the oceans rise, and storms become more deadly. Western rangelands become a little drier. Insects and disease creep a little further north. And the air we breathe gets a bit more toxic. If just a 1 degree rise in the global average temperature is responsible for what we've seen, consider that scientists have projected an additional warming of up to 2 degrees by 2050. In our lifetimes, we're all likely to feel its effects, because as you've seen, there's much more to global warming than just the heat.
And most humans are environmentalists because they don't feel like they're a part of the environment, and they are.
Last fall, we had 2 storms. The shoreline eroded 290 feet in a week. Since 1932, we've all figured it out.
Okay, thoughts? No thoughts? Alright, let's each person talk so we can all sit with that person. Yes?
So when you're talking about those big filters that
Yeah.
Conversion of them, they're gonna turn to like limestone. That's
Yeah.
what it is.
You're essentially taking the CO2 out of the air, you react it with sodium hydroxide, it makes calcium carbonate, it makes calcite, which you have in limestone. That's a fairly, harmless material. You can spread that on roads, you can spread it in fields, that's basically what you're making. So that's totally inert, harmless material. You can, use it for drainage ditches, for building up riverbeds, for development. I mean, it's non-toxic, so.
And how often have you changed those things?
Well, I don't know. That's a fairly optimistic view. There's another, that same guy you saw, Wally Bruckert from Columbia, is working with a few people with prototypes of plastic mesh that you do the same chemical reaction, but you do it in something the size of a semi. Okay, and you can put it anywhere, like I said, because CO2 is everywhere in the atmosphere. You don't have to put those right by the power plants where you have the CO2 coming out. They can go anywhere, and they estimate 1 million of those would absorb all the carbon that we're putting out right now. Yes, say 1 million semis. Well, there are hundreds of millions of cars out there. So these things could be mass-produced. You're gonna generate jobs to manufacture these things, to install them and so on. And the technology is a very simple chemical reaction. So.
How much would it cost?
What's that?
How much would it cost?
I don't know the economic factors on it, cost versus output, but.
It's like a world effort, so everybody's gonna pay for it.
Yeah, well, certain countries have more resources than others, so the ones that have more resources have to lead in that respect. Jesse?
How come we have all these ideas and nobody jumps on it?
We are jumping on it. There's a lot of stuff. Well, under the Bush administration, all the tax credits for solar power and alternative energy were done away with, and those have been reinstated under the Obama administration. So we're headed in the right direction. It takes political leadership to push for these things. Kyle?
Well, what happens if everybody started to use solar panels? We only have like a couple, but the majority of the population doesn't use solar panels, and solar panels are subsidized by the government. So what happens if everybody starts to use solar panels?
Exactly. So what you have then is you have private industry taking the lead. You have companies that, once they get enough production in line and the price comes down, is more competitive with oil, those private companies will pick up the slack. They don't have to be subsidized like the oil corporations are. So they pick up the slack, the technology is readily available, more people start using it, those companies have an economic incentive to produce those, even without government subsidies. So the private sector takes the lead. Just like we did when we had the Apollo program, and that was research and development by the government, and out of that came a lot of private industry applications of that technology. So, you know, you'll be able to go down to the local energy store or whatever, you know, order a couple of solar panels, hire a contractor, it'll come out, put it on your rooftop. In Greece, they have, because they have so much sun, of course, almost every house I saw has a tank on the top, a hot water tank connected to solar panels. That's how they heat their hot water. And you don't have to have sun year-round. So during the day, when they have a few hours of intense sunlight, it heats the thing up. It's 250, 300 gallons. At night, they use the hot water. So, what else?
Do you have a hybrid?
I don't, but I do have a Honda Fit, which is a nice small car, so I get about 40 miles to the gallon on the highway and 32, 33 in the city. Yeah, so that's something you can do, right? You can buy a hybrid. What else can you do to minimize your carbon footprint, as they say, to use less carbon? Turn the lights off, as they were training those middle school students. Turn the power down your computers.
There's gas emission laws for like my backpack blowers and
Yeah.
my everything.
Yeah, for everything.
So they are putting stuff in.
Oh, absolutely. That was done away with under Bush.
Like cars, like, you know, by school zones and stuff.
Yeah. Well, yeah. What else can you do as an individual besides buy a hybrid? What's that? Plant more trees. Okay, you could get involved in your local community garden projects. There's greening rooftops projects where they actually plant gardens on roofs. You can get involved in that. You can go volunteer at your local cooperative extension. What else can you do in terms of products you buy? What's that? Fluorescent light bulbs. Yeah, actually they're phasing out incandescent light bulbs altogether. So fluorescent light bulbs. What else can you buy that'll lower your carbon?
Well, you can't see LED light.
Okay. What else? Give me more practical things you use every day.
Paper.
Okay, yeah, paper instead of plastic. You can get one of those carry bags, right? I have like 20 of them. All right, when I go to the store, I pull out 5 or 6 of them. They give you a nickel back for each one every time you use it. I'd say it's just a nickel, but what if you use 300 or 400 bags a year? That's a few dollars, $10, $15 to save. Every single person is doing that. Think how much plastic we save and how much oil goes into producing that plastic. How about energy-efficient refrigerators, washers, dryers, microwaves, all that stuff? You know, they have a little energy guide on there. You can calculate that out, how much you would use per year, how much you're saving in terms of your electricity cost. Save electricity, that's less oil and coal used to produce that electricity. Right? Lower your water intake. All right? To supply all that water and pump all that water around takes electricity. right? And that's ultimately oil and gas. What else could you do?
We can shower once a month.
What else could you do? Most of you are not going to. All right.
Americans, we have issues with that.
Well, we're all consumers, and there's a certain pressure, societal pressure to consume. Okay, but you can make choices. You don't just blindly walk into a store and blindly walk around. All right, that's why it's my responsibility and other teachers at the lower levels to educate people as to what they can do. That way, you empower yourself, and you don't feel so helpless when you watch a video like this, that you realize that you can do something. And if 50 million people do that something, that adds up to a lot of saved carbon. So it's not trivial, these little things that you do. You say it's just a drop in the bucket. That's not the point. The point is to get everybody on board, at least the majority of people on board, in doing these green things.
Instead of like a truck here and there, it's like.
Well, you can do more. Obviously, the world has a thirst for oil, has a thirst for coal, right? You can get involved in the energy industry in low carbon emission ways of producing oil, of using coal. They were talking about coal gasification. They still haven't solved the carbon emission problem. You can get degrees in environmental science, environmental chemistry, atmospheric chemistry, meteorology. Most of you are not going to be scientists, but you can get involved on just a grassroots level with local people who are scientists, who are trained to deal with these things. Local community projects for elementary school kids and middle school kids, going out planting an organic garden. California, they have all kinds of programs for kids, like in grade school and middle school, to go and do organic farming. Yeah.
My high school did that.
Yeah. So there's all kinds of things you can do. All right. So we have a test tomorrow.
What?
Screens and hydrology.
No.
Are you playing?
Guys, screens and hydrology,
Are you
glaciers,
playing?
and climate change. Hydrologic cycle, stream flow, glaciers, and climate
Oh, but
change.
if you drop the lowest test grade,
I do drop the lowest
and
test
this is
grade.
our last test, right?
This is our last test. Why are you guys so shocked? They told you this a week ago.
That's what I'm saying.
I'm sorry if you forgot. All right.
Shut up. Shut up.